Hello. Hello, good afternoon. Welcome to this first live streaming of my function block programming using MENTA, Schneider's MENTA engineering tool. So for today's lecture, it will be uh, control logic programming of twin exhaust fan. As you can see in my screen, I have here a typical example of a twin exhaust fan. Okay. Now our scope for today is how are we going to write the control logic program for this equipment. So just give me a minute to prepare everything. Yes, we have one viewer here and top Lothario. So let's just wait for some viewers before I will try to start this one. So I started early so that we will be able to wait for some others to join us in this live streaming. Actually, what is happening is right now here in Philippines, we have a typhoon somewhere in Central Luzon. So right now I'm here in Bicol region, which I believe our typhoon signal number here is signal number 1. I do hope that this live stream will not be affected by this typhoon. Okay, so I have here one viewer. Thank you for joining me here. I'm hoping there will be some uh, future BMS engineer who are interested in joining me here. Just give me a minute. So I will start exactly at 5 p.m. Hopefully, some will join us at exactly 5 p.m. Okay, guys, just to give you an idea, what we're going to do is to explain what are the steps in preparing the control logic program for this simple twin exhaust fan. Okay. Now, actually, we are using this system in we can say in an area wherein the several comfort rooms are located. Uh, we can use this also in kitchen. We can use this in area wherein we need to vent out the air from the area to outside. Okay. Now, actually, in my previous project, we used this in areas for female and male restroom. Then we can have also this one in some areas like kitchen, just what I've said, kitchen and corridors and some areas where we need to vent out the air. Okay, so today what we're going to do is to prepare the control logic program for this one. Okay, so just 7 more minutes, we'll be starting this. I hope someone will also join us. Anyway, this will be posted uh, in my YouTube channel. You can just watch it later if you will miss this live broadcast. Okay, so I still have 7 minutes, so let's wait for some others. Okay. I just started this in advance so that I will be able to prepare all the things I need to use in this live broadcast. My slides and the uh, okay, let me start also my MENTA editor so that I will be ready. Okay, guys, those who are here, you are free to put your comments if you have any query. I'm hoping the one who is going to watch this or who is going to join us are future BMS engineers. Okay, so we'll just wait. Okay, 2 more minutes before we will start. Okay, 1 more minute. So we are about to start this live streaming. Actually, it's already started, but I'm just going to start the lecture at exactly 5 p.m. in my time. Okay, guys. To begin officially, this is your host, Santos Capelan Jr., always wishing you a good day. So, what we have here today, guys, is the uh, our lecture all about function block programming. Okay. Now, as I said, this one is for those newly graduate or new engineers who are wishing to join the field of building automation or building management system. Okay. Now, to give you an idea, how are you going to prepare the control logic program if you have this kind of equipment? Now, what I have here is the twin exhaust fan. Okay, I have here EF1. I can say this one is EF1 and this one is EF2. Okay. Now, if you have a motor like this, there will be always a motor control. Okay, so what I have here in this board is the motor control. Okay, so let me go to the, okay, now this is my motor control. So in the motor control there will be some indication lamp. Okay, so I have an indication lamp here. Most likely you will have an indication lamp in your motor control like EF1 run status, then EF1 trip, then EF2 run status, then EF2 trip, then we have also the power, then we have here the two selector switches, right? Now the selector switches enable us to run the equipment in manual and automatic. Okay, so we have here also our start stop push button switches. Okay, in manual, when your selector switch is in manual, we can operate this equipment manually. Okay, now usually we are using manual operation just to have a second option if we have the scenario, let's say the controller that controls the automatic operation of this is having some problem. So if this exhaust fan is serving a critical area like a battery charging room, then it is a must that we have to run this one of the fans manually. Okay, so that is the purpose of selector switch here and the motor control also. So we can run it in manual and automatic. Now I have here a PLC. Okay, now because I'm going to train my students in machine automation, how are they going to write the control logic program for these two equipment using the PLC? So we will be using a ladder diagram program. Okay. Now, but for this lecture, we will be using function block programming wherein we can upload it to a DDC, direct digital control. Okay. Now, if you have this kind of equipment, the first thing that you need to learn is what are the control points. Now, in building management system, we have the control points. Okay, so let me go to the next slide here. Okay, wait a minute. Why it's not showing me here? Okay, wait. Okay, so just a minute. Let me go out of the. Okay, then. Okay, now let me share my. Let me share my. Okay, now I think it's already there. Okay. Now, guys, as I said, you know already the equipment. Okay, then you know that there are two fans. Then you know that there will be a motor control for these fans. Then there will be some field devices that will be installed for this fan, like the differential pressure switch that will sense the airflow being delivered by the exhaust fan. Okay, so you have to know actually what are the approved. So we can say these are the approved BMS points for the equipment. So apart from knowing these BMS points, one of the documents that you need also to seek or to look in the specification is the sequence of operation. So how this punch will operate. Now, to begin with a very simple programming, as I said, this will be for beginners. Okay, so we will be using a very simple one. So first, we know already the BMS points. So we have two funds, EF1, then EF2. So what are the typical points that we can uh, monitor and control in these funds? So first, we have our auto status. As I said, we can uh, we can we can operate the equipment in manual and auto. So we need then auto status. Now, auto status will give the signal to our control logic program to take in control. Okay. Now, in building management system or in building automation, the equipment will be controlled by BMS only if it is in automatic mode. So that is very important points for us to be able to control it in automatic. Okay, so I need this status. Again, EF1 auto status, these are bolt free contact. Now guys, in building management system, we have the VFC. This is stands for bolt free contact from MCC. Actually, MCC is motor control center. Okay, but maybe you will see there MCP, motor control panel. Okay, then we have also here. Let me go out of the. So we have also here the EF start stop command. Okay, now in building management system, there will be two scope, control and monitoring only. Now for this equipment, we need to uh, perform control and monitoring. Okay, so the points that we need to prepare for our control program is EF auto status. This is a monitoring point. Then EF start stop command. This will be a control point. Okay. When we say control point, this will be the one that will control the equipment, or it is the same as saying this one will be the one to start and stop the equipment. Okay. Then another one is EF run status. EF run status, again, it is a volt free contact from MCC. Okay, now maybe it will be taken from the normally open contact from the magnetic contactor. Okay, again, it's a volt free contact. Now, maybe some of you will ask why it is volt free, meaning there should be no presence of any voltage level in that contact. Okay, now contact can be normally open and can be normally closed. Now we are going to use a normally open contact here. Okay, then apart from that one, we have this EF trip status. Again, that is another volt free contact from MCC. Okay, then EF airflow status, BFC from DPS. Now DPS stands for differential pressure switch. Now actually guys, the DPS, that is a device wherein it will sense the differential pressure across the fan. So as you know, for the fan, we have the supply and the suction side of the fan. So we are installing a differential pressure switch across the fan. Okay. Now fire alarm relay module or fire alarm signal. Okay. Now fire alarm signal, if this equipment is used for ventilation, now basically it is a norm that when there is fire, we need to shut down this equipment. If this one will be controlled by fire alarm system, so they will be in the control panel. The fire alarm people, they will install one control relay module there that will cut the power or the control power from our control panel so that the equipment will stop. Okay, so that is the purpose of this fire alarm relay module, wherein we can get also the uh, fire alarm status. Now, if we cannot get from this one, the fire alarm people will provide us the bolt-free contact from their panel. Okay. Now, the same points will be associated in our standby fan. Okay. So I'm using here is duty and standby fan. So meaning the very first sequence of operation that we're going to use is for duty and standby operation of the equipment. Okay. So how many points in each fan? So 1, 2, 3, 4, 5. 5 points. Then plus 1 fire alarm signal. Okay. Now guys, trip status is very important also because this one is duty and standby. When EF1 trips, then that's the time our standby or EF2 should kick in. Okay. So as I said, get to know the equipment that you need to control, then get or learn the basic control and monitoring points as I have here. Then know, which is very important, the approved sequence of operation. Okay. So we are going to use a very simple one, duty and standby. Okay. Now, will be the fun part of this live streaming. We will begin now the control logic programming. Okay. So let me just go to my share. I will share. Okay. Then wait a minute. I will share this one. Okay, so I hope you are seeing my, let me go to my, okay, then I will, okay, I'll need to stop this, then I will share the share screen. I will share now my uh, function block programming. Okay. Okay, guys, I hope you are seeing this one. Okay, now let me start. Okay, so this is my okay. Now new. Okay, guys. Now I'm going to start the uh, control logic program. Okay. Now, as I said, we are using this building operation MENTA editor. This is a product of uh, SCHNEIDER. Okay. Now, actually, this is an old version. Okay. Now here, when you are going to start a new control logic program, of course, this software will ask you what will be the controller or the DDC that is going to control and monitor this equipment. So we have here a base controller. Okay, this one is tax center 401C. Actually, guys, this is just an example. Maybe if you will become a BMS engineer and you will be joining solution providers like Honeywell, Siemens, Delta Control, and other Schneider, then they will be using different engineering tool. Okay, but the concept is the same. Of course, for this one, it is asking us what will be the controller that you are going to use. Okay, so I'm going to use a base controller. When I say a base controller, it is not a modular controller wherein the IOs are built into that controller. Now here, you need to add IO, input and output modules. Okay, so I have here Taxenta 401C. Okay, then I need to, okay, now maybe you can do the version also here. Now, what is important here, okay, just disregard some of these options here. What is important here is you need to add IO modules. By the way, IO modules is the one that you are going to use in connecting the field wiring. When I say field wiring or the physical points, those are points that are coming from the motor control and from the field devices going to your controller. Now, your controller, like if you have this 401C and some IO modules, of course, it will be housed in an enclosure, okay? So your technicians, if you are the BMS engineer, you will be asking your technician to pull cables from motor control and field devices going to your DDC panel, okay? So inside the DDC panel, these are the DDCs or the controller, okay? Now, I have here several IO modules here. Okay, so we will not be using this, all of this. We will just be using one or two of this one. Okay, now I'm going to use this 411. Okay, actually, this 411 are for digital inputs. Okay, so I will just say, okay, so these are for digital inputs that will handle the monitoring of the physical points. Okay, then again, I need another module wherein I can give the control command or the start stop. Now I will be using this 421. Okay. So M1 is Taxenta 411. Okay. These are the module. I think there will be 10 input channel here. Then this one, I guess there will be 5 uh, output channels. Okay. So I will just say okay. Okay, now for the program specification, I need to give a name for my program, okay? So I will just say this one is for, what will be the name of this? I will say Twin EF, okay, let me use Twin EF CTRL, okay? Now, I think that will be enough to start my control logic programming, okay? So, sorry if there will be some delay at your end. Okay. Now let me see. Okay. So here. Okay. Now let me continue. Okay. Now we already know the points that we need to use in our control logic program. Okay. Now here in the flow basic flow of information or in programming, we have these things. Okay, let me just give some comments here. So first I will say input. Okay, let me just make it a little bit bigger. Okay, so just submit. Okay, so Tahoma. Okay, then I will use bold. I will use 12. Okay. Okay, so I first I should have the inputs. Okay, Control C, Control B here. Okay, now you can use also here the copy paste. Okay, so this one I will change this to process. Okay, then this one I will change it to output. Okay, now so the first thing that we need to use is the input blocks. Okay, so right click. Then simple block. Okay, simple block. We have so many blocks in here. Okay. So as I said, our sequence operation is duty and standby. Okay. So we will be creating this very simple one. Now, okay, so I will use a DI here. Okay, so that is a digital input block. Okay, so sorry for that one. So that is a, okay, this will be a digital input block. Okay. Now, as you can see, it's showing that it is a normally open. Then it should be connected to the uh, input channel. Okay, so let me just give an identifier for this. So I will say this is the very first important point for our system or for our equipment. So I will say this one will be EF1 HOA yes. Okay, so that is EF1 and tap out status. Okay, now I will just give an description for this one. Exhaust fan auto up. Okay, let me start with hand up out auto status. Okay. Now, guys, what is important here is the binding. Now, when you say binding, you are going to bind it or tell your program where are you going to get the information, okay, or the real-time value at the field. So now I'm going to specify my IO module. Now, as you can see, there will be 10 input channels. So I will use the first input channel, okay. Okay, now, okay, so the points are already binded to the input terminal. Then we already identify the first digital points, okay. So now the next thing that we need to do here is to copy this. Control C, Control V, okay. So we have around okay, so this one I will just change the EF1, okay, trip status. Okay, now I will just remove this. Now this description is optional, but what is it is important to specify the description, because let's say you are a BMS engineer of a solution provider, then you left the company, then someone that will take over your work will be able to understand your control logic program if you have some description here. Okay, so this is just to give your predecessor or the one that will replace you an idea what are these points, especially if the guy is also a beginner. Okay, now I need to bind this one. I have used already the first input channel, so I will use the second one. Okay, I will say okay. Now what else do we need? Again, I control B. Okay, so I need here a fire alarm. Okay, so this one will be fire alarm, fire alarm STS. Okay, so uh, let's remove this description. Then let's bind it. Again, binding is just telling our DDC where it will get the real-time values. Okay, now change this one. Okay, okay, fire alarm. Now this three, okay, then I need also one. I have there a simple block also. Okay, let me copy this. Control C, Control V. Okay, so what I have here is the I will change this to EF1 air flow, yeah, airflow. Okay, airflow status. Okay, then let's change the terminal. So this will be 4. Okay, so 1, 2, 3, 4. Okay, now we already have the almost all of the points for the first exhaust fan. Now let me copy this. Okay, I'll copy this. Control C, Control V. Okay, because I'm going to specify also the Control C, Control V. Okay. Now, this one we will just change this for this one will be F2. Then, okay, okay. The binding is 1, 2, 3, 4. So we will be using 5. Okay, okay. So this one will be, okay, so this one will be 2. Then the binding will be using 6 here, I guess. Okay. Okay, then this one is for 2 also. So the bind, we will use the 7. Okay, so how many points we have here? 1, 2, 3, 4, 5, 6, 7. So we already occupied the 7 points in our IO module 411, the first 411. Okay. Now, the I need to specify here the two control points. Okay. So what I need to use here is a DO. Now, DO is a digital output block wherein, as I said, this will be the one to start and stop our equipment. Okay, so I will say this one is EF1 SS, start to stop command. Okay, now the bind. Now the binding, you are going to use the module wherein there will be digital output points. Okay, so as you can see here, there will be 5 digital points for this module, this 421. Okay, then okay. Now I will copy this, Control C, Control V. So I need another because we have twin exhaust fan. Okay, so I will use this one too. Okay, then the binding I will change to 2. Okay, 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 now we almost specified all the what to call this one, all the needed control and monitoring points. Okay, so let me go back to my MENTA editor. Now we need to what is missing now is the process. Now the process actually is the let's say we need to complete the logic. Okay, so the inputs or the conditions need to reach the output point. Okay, so what I'm trying to say here, the sequence of operation. Okay, let me make a comment here. Comment. Okay, uh, duty duty standby operation, and duty fun trips, then standby fun will kick in. Okay, so that will be our very simple uh, sequence of operation. Okay, so that this will be our simple sequence of operation. Let me put it here. Okay, so duty standby operation. When duty fan trips, then standby fan will kick in. Okay. Now, guys, as I said, if this equipment will be used for ventilation purposes during fire scenario, or let's say there is a fire in a building, this equipment should stop automatically. Okay. Now, maybe you will say, as based on my experience, this one, if it will be controlled by fire alarm system, this will be automatically controlled also by fire alarm. But for my side as a BMS engineer, I need to stop it also when there is fire, because let's say the fire alarm relay module installed in the motor control fails, then my system can also stop the equipment during fire. Okay, during fire scenario. Now here we will be using simple logic gates here to accomplish our very simple sequence of operation. Okay. Now, simple block, we have, as I said, we will just be using gates. Okay. So I'll be using an AND gate here. So guys, if you are watching my channel, actually I already done this several times, and maybe you will find it repetitious. But as I said, this is just for beginners, and this is to help the new engineers who are wishing to join this field of engineering. Okay. Now, when the basic sequence of operation, or the basic sequence in starting this equipment, the very basic is I can start this equipment if it is in auto. Okay, guys, if you are using this end logic gates, you should be familiar also with the truth table of this. Okay. Now the truth table of this, as you can see, my AND gate, there are two inputs. So these are the input side, or the input ports. Then we have here the output port. This is the output port. Okay. So the truth table of an AND gate is when both inputs are 1, that's the only time the output will become 1. Okay. So that is the truth table of an AND gate. Now, I can start I can start this equipment if it is in auto. Okay. Then there should be no trip condition. Now, trip condition is wherein, let's say, during operation, your fan is running. Then after some time, because let's say the fan is belt driven and the technician installed the belt so tight, and it gives some stress to the motor, then eventually the current being drawn by the motor will exceed the full load current of the motor. Then the setting of the overload protection exceeds, I mean, the current being drawn by the motor exceeds the set point in the overload protection, then this equipment will trip. So it can run if there is no trip condition in the motor. Okay, so the keyword there is if there is no. So meaning I'm going to use a negation here, or an inverter, or a NOT gate. Okay. Now this is a NOT gate, guys. Now NOT gate is being represented by this triangle with a small circle in front of it. Okay, so again, the truth table here is one input. This is the input port, and this is the output port. Now, if we have one in the input, the output will be the reverse of the input. Okay, so if I have one here, it will be zero here. Okay, so I will be using this also. Okay, then I'll be using this as my second input for my uh, for my first and gate. Okay, so let me see. Where are you guys? Okay, so anyway, you can just watch this also, because it will be also saved in my channel. Okay, now what else? Now again, I'll be using another AND gate here. Okay, so I'll be using it again. I can start this equipment if there is no uh, if there is no fire. Again, the keyword there is no. If you will notice, if there is no, so I'm going to use a NOT gate there. Okay, so NOT gate. Again, I'm going to use a NOT gate here. Okay, then I will connect it here. Then I will connect it here. Okay, so the output of the first AND gate, I'll be using it here. Okay, then, okay. Now, uh, my EF1 control logic is done. So I need to, now for the EF airflow, it will be used for monitoring. Okay. So later, when we develop this control logic program, we will be using this one also. Okay. So, but for the time being, I will not use this one, uh, or I will not insert it in the control. This one will be only used for monitoring purposes. So maybe what I can do here is to uh, get an alarm. But later I will do that one. Okay. So let me just finish the control for the next or for the standby fan. Okay. Likewise, I will be using the same approach for this. Okay. So just to make it, I can copy this Control C, Control B. Okay. So that I will not be wasting time. Okay. Okay. So I will remove this and I will remove this also. Okay. Now again, if it is in auto, okay, then there is no trip. Okay, then yeah, there is no fire. There is no fire. Okay, so I can create a node here. In creating a node, when you say creating a node, you are also going to use the output of this gate. So I can create a node here so that I can use that output also as one of the inputs in my AND gate here. Okay. Now guys, again, I can start this if there is no fire. Okay, then it is in auto. Oh wait, this one is not correct. Okay, if it is in auto, okay, then there is no trip. Then the other condition here is when this one trips, that's the only time this one will kick in. Okay, so I need to use another AND gate here. Okay, so let me use an AND gate. Okay, so I have an AND gate here. Okay, now I have to connect this as the input here. Then if it trips, so trip, where do I need to create the node? Is it from here or from this one? From the input port or from the output port? If your guess is from the input port, you are correct. Okay, so I need to create a node here. Okay, so I will be creating a node here. Okay, then let me pass it here. Right, then let me pass it here. Okay, so let me just make it a little bit. So I want to make my control logic program neat. Okay, and I say neat. I don't want my lines, my flow lines, intersecting, or I want it to look more professional. Okay. Now this will be our control logic program that will try to accomplish the very simple sequence operation. Again, to reiterate, this equipment will run if it is in auto, then there's no trip and there's no fire. Okay, so it will be using these two AND gate, then these two inverter here or NOT gate. Then likewise, I'll be having these three uh, AND gates, then one. Okay. As I said, later we will include the airflow. Okay. Now I'll be limiting my live streaming within 1 hour. Okay. So how are we going to know that our control logic program is or it meets this condition? Now, the beauty of this MENTA editor is we can simulate our control. Okay. First, let's just save this one. Okay. So I will save this. Okay. So I need to specify a name for this one. Okay. So I will go to my PC, then see. Okay. So I have here my blog video. So let me just show you where I'm going to put it. Okay. So where is my live presentation? So I put it here. Then I will put a name here. F function function block program part one. Okay. So this will be part one. I hope you will join me in part two. If you will not be able to join me in this live streaming. Anyway, I already saved it. Then there is no error, meaning I don't have any programming error here. Okay, so there is an option here that we can simulate. Now, if you come to this far or if you come to this point, then there is no problem with your uh, control logic program. Now, guys, the beauty here is you can see the signals. Okay, So I have here 0 signals. Since these are digital, so we are expecting only two values, 0 and 1. Okay. Likewise, our AND logic gates, it will also produce an output of 0 or 1. Again, our digital output will produce 0 or 1. Okay. Now, if you will see 0, it means the equipment will not start, or it is in a stop condition. Stop condition. The output of this are 0, 0. And this digital input, the condition now is 1. Okay. Now, as you can see, this column here will be showing our physical points. So 1, 2, 3, 4, 5, 6, 7. So I have here 7 physical points. When I say physical points, these are the points associated with physical wires. So meaning from control panel or field devices, you will be pulling cables to core going from MCC or field device going to your DDC panel. Okay. So those are physical points. Then we have also this. Again, we have 7 these physical points, and we have 2 physical points for our digital output points. Okay. Now here we can play with the inputs. So first thing you need to do is to execute your program. Okay, so as you can see here now, it's already cycling. When I say cycling, it will check all the inputs, then produce the necessary output. Then again, it will keep on cycling like this. Okay, it will be waiting for some condition wherein it will change also the necessary output. Okay. Now, as we said, the equipment, as I said previously, the control will take in effect when the equipment is in automatic. So first, we need to put our fans in automatic. So EF1 and EF2. Now as you can see, EF2 and EF1. Now, as you can see, immediately our control logic program started the fan here. So duty standby operation, when duty fan trips, then standby fan will kick in. Yeah. So this will be our control logic program. Now, let's say, how about if my EF1 trips? Okay, so if EF1 trip, of course, obviously, there's a problem in the motor. Our fan EF1 will stop. Then my control logic program try to start my standby fan, which is exactly the sequence of operation, duty standby. Okay. Now, what happens if someone, let's say the technician, go to the field and try to reset the trip condition in EF1? So let's say that the trip condition is rectified and it was reset. Okay, again, our EF1 will run because based on our simple sequence operation, duty fan will always be running, and standby fan will kick in when duty fan trips. Okay, so that is a very simple scenario. Okay. Now, the other thing that we need to check here is when there is fire, which this is very important, guys. When there is fire, this equipment should stop. So let's simulate a fire. Okay, this one. Okay, now as you can see, our equipment stops, even though uh, our equipment stops because we said that if there is fire, this ventilation fan should stop. Okay, now let's remove the fire. Okay, so again, let's say our EF1 is running, then this guy, the technician, go to the panel, then remove the uh, EF1 selector switch from auto. So from auto, he remove it and put it to off. Okay. Okay. As you can see now, as you can see here, guys, uh, the problem is if it was removed in auto, then it is not being covered by our control logic program. So again, as the BMS engineer, you should consider this scenario. Okay, so what you will do, you need to include this scenario in your control logic program. So let me just try to include it here. Okay, so what I will do, because we can say EF1 fails also. If it trips and someone remove it from automatic, then of course our standby fan should kick in. Okay, so what we will do here is we will go back to our editing mode. Okay, now guys, what I will do, okay, so I will try to inject this logic to cover that scenario. Okay. Now I will remove this one here. Delete node. Okay. Maybe this is the last portion of this live streaming. Okay. Now uh, I need another end here. Okay. So I want to add an end block. Okay. Then an or here. Okay. Hmm. I need an I will use an OR block. Okay. Maybe this simple logic will solve this issue. Okay. Now, if this one is not in auto, okay. If this one is not in auto, again I will use here not gate. If not in auto, okay, I will put it here. Okay. Okay. I'll be coming here. Okay. Then okay. If it is not in auto, okay, I'm covering if it is not in auto, then, uh, okay, so this one I will use it here. So this is the first condition wherein I can start the standby fan. Then another condition is where it is not in auto, but uh, there is no fire. It is in automatic and there's no trip. So I'm going to create a node here. Okay. I'm going to create a node here, then use the output of here, this one. So there are two scenario here now wherein I can start the standby fan. First is when it trips. Okay, this is the one. Okay, and it is in auto, and there's no trip in my fan too. And or I'm using an or here. It is removed from auto, and of course I can start only this one if there is no fire, it is in auto, and there is no trip. So I'm using the output of this AND gate to be the input also here. Okay, because I cannot immediately when they remove it in automatic, I cannot start immediately my standby fan without knowing or without considering that the fan also is in auto, there is no trip and there's no fire. Okay, so let me again save this one, save. Okay, then option, let's simulate it, then execute. Okay, now, okay, so what happened here, it is not in auto. As you can see, it is now being uh, implemented by this logic. Okay, so let me say I will put this in automatic. Okay, now it stopped. Okay, then EF1 starts. Okay, again I will put a trip. Okay, if stand duty stops, then standby kick in. Okay, now let's say someone rectified the problem, so we don't have a trip. Okay, then maybe the technician went to the site, then he want to do some maintenance. Let's say he heard that this exhaust fan is creating some noise. Then he went to the control panel and remove it in automatic. Okay, then as you can see, EF2 or the standby kicks in. Okay, so the simple sequence of operation is being handled by our control logic program. Guys, I'm not saying this is the, for me, this could be the one of the best solution. But again, in programming, there are several solutions to a problem. Maybe we can use here an expression block to get away with this several combination of logical gates. Okay, maybe two expression block will just uh, is a equivalent of this control logic program using several and gates. Okay. Now, guys, this will be the part one of my live streaming. I hope I can uh, see you in my next live broadcast. Okay. So thank you for these two guys who joined me during this live streaming. Thank you, and maybe in my next live stream, I will be able to get some live audience from you who will be able to see this live streaming. Okay, guys. So once again, I hope in a little way I have given you guys some idea how are you going to prepare function block programming for the equipment. Then I hope you will join me next time in my live streaming. Again, thank you. I already used 1 hour here. So as I said, I will be going live 1 hour only. I already exceeded to it's already 1 and 2 minutes. Okay. Anyway, thank you for joining me. And before I will end this live broadcast, thank you, and I do hope to see you soon in my next live streaming. Thank you. And before I will end, God bless us all. Let's all be safe and bye for now.